Hi, everyone, and thank you so much for joining MRF System Data and Intelligence in Real-World Applications presented by the Recycling Today Media Group. I am Marissa McNeese. I'm the managing editor of Recycling Today magazine. I'll be moderating today's session, and a couple quick housekeeping notes before we get started. First, the session is being recorded. Second, we do encourage you all to ask questions during the presentation. We will get to those throughout the presentation as they come up. And of course, if your question is not answered during the presentation, there will be time set aside at the end to get to any questions we weren't able to answer during the presentation. A little bit about today's session. The waste and recycling industry, of course, is rapidly evolving, and having data and knowing how to leverage it is vital, especially with smarter equipment and the more complex systems. Today, we have Thomas Brooks, Chief Technology Officer at BHS, presenting today's session. Thomas is leading new technology and product development efforts across the organization with an emphasis on bringing new products to the market. He joined BHS subsidiary National Recovery Technologies in January 2014 as the engineering manager and has a background in leading new product development and product issue resolution for aerospace, industrial, biomedical, and automotive customers. So without further ado, I'm going to go ahead and turn it over to Thomas. Thank you so much for joining us today.
Thank you, Marissa. Good. Well, so what we want to do is obviously talk a lot about data, what we're doing with technology, how that's impactful, what's going on, what we're seeing kind of as state of the art, and what we're using for technology implementations across the board to really drive some unique changes that we see in the space. And so as we're getting into this, one of the things that I wanted to do is just kind of give a brief introduction for bulk handling systems, BHS, and really kind of highlight the fact that bulk handling systems is really kind of a family of companies that have been put together really with a strategic mindset of how do we reach out and solve many of the big challenges that are in the waste industry. And, really starting with kind of its inception in the early 70s when BHS was first founded, and then progressively adding companies either through acquisition or through growth and invention and creation, basically building out this family of organizations which make up really the ability to separate all different types of waste and to implement and solve problems that we're seeing really around the world in many unique ways. Everything from AI robotics, which are usually kind of the hot topic, to density separation, which we do through air, our optical sorting and automation technologies, which we're doing through NRT. We'll talk about those as well today. And then a topic that we can spend some time on, not as much of a focus at this session, but really around organics. How do you deal with that organic fraction that's sitting within the waste stream and effectively use that in a smart way? And then our total fiber recovery project, which is really around solving some of the intricate issues that we've seen over the past several years around fiber and what do you do with that material and how do we move it into new and unique markets. So really starting off the conversation is really at a high level, what's driving our push towards technology, towards data, towards new products, towards introduction of those and trying to be successful. And really it centers around this concept of trying to really empower a healthy waste processing. And so what does that mean? Well, in order to understand what healthy waste processing is, maybe we talk a little bit about what's probably considered not as healthy. What this graphic is really showing is kind of the linear recycling or linear material processing that's taking place today. And in this case, most of the material, if not all, is basically moving through the system. Whatever is reused, so to speak, is done on a very personal level. Everything else is going to landfill. And really our driving purpose within BHS is to try to eliminate that. And with an open thought that, it's not just simple as turning off a faucet, you have to have meaningful ways to solve these solutions. And so what BHS has really done is ingrained itself in a number of the different recycling points and material recovery points within circular economy, right? Trying to move away from that linear position into a more circular position where not only are we trying to reuse materials, but we're also converting those materials back, right? BHS for a long time has been involved in material recovery facilities, basically as well as organics, and now kind of expanding our field into both the mechanical recycling and chemical recycling space. We have facilities and equipment going into each one of those, really trying to drive the circular perspective of how do we help society in general to come to a better place. And I think this is the reality of what we deal with on a day-to-day basis. And really, you know, as I speak for the entirety of the BHS organization, this is the driving point for all of us. And whether you're seeing that through our service, through our production, or through our technology, this is really what we're trying to push to really minimize what you see in this graphic is the portion on the left, to really reduce that amount of material that's going to landfill and drive core recycling and our ability to drive circularity, whether that be through biofuel, organics, or plastics, paper, all of those different aspects, C&D, we're involved in all of those. And how do we move those forward and carry those into an effective way, right? So when we talk about circularity, there's a couple of pieces that, irrespective of what materials you're trying to move, there's a couple of areas where there's really some limiting or barriers that are limiting our effectiveness in circularity as a whole. Those center around high cost, high operational costs, which can center around staffing challenges that we might face, timing and flexibilities. We'll talk a little bit later on about our autonomous processing systems that we're putting forward. It can talk about just the general metrics of how are you driving effectiveness within your facility. It's not uncommon today for us to visit a lot of facilities around the world, and most of that information that's gathered or used for metrics of operation is really manual. And that's kind of the state of the art for the majority of waste processing, irrespective of what kind of processing we're looking at, right? And what this means is as we can solve these problems, we're really building on not only the aspects of adding more functionality and increasing circularity, but we're also driving the commercial aspects of really creating a healthy and functioning business, which just further encourages capital investment. And I think you're remiss to not talk about the two in the same piece. It's not just an ROI portion that goes into it. It's also how are we enabling a better future for not only ourselves, but our children and the generations that are coming to follow, right? So as we go through this discussion, really the purpose is to talk about some of the core challenges. We're not going to talk about all of our technology portfolio. We're going to focus on about 3 different ones, but it's also for us to have a conversation about what challenges are in the industry and how can we better help to solve those. And a lot of this comes from our industry experience, but it also comes from our customers and partners that we've progressively engaged with to really drive a better understanding. So again, I'll highlight what Marissa already commented to. The best way for us to go forward is to really have an interaction in this way. I know virtual is always a little bit difficult, but as anyone has questions that they want to bring up, feel free to use the Q&A functionality within the Zoom meeting, and I'll go through those and try to get to as many of them as I can. If we miss a few, we'll try to catch up on the back end and have some time at the end for more discussion. So with that being said, one of the core places as we talk about trying to drive industrialization into material processing and material recovery facilities, it's really about the data. One of the things, as I've probably told the story many times, my background is really coming from aerospace, biomedical, automotive. And in those cases, having data and understanding what your processes are doing is paramount. The issue that we face within waste handling in general is the fact that the material comes in any shape, form, fashion, anything that we could look at, right? And so very early on, we recognize that there's a core need around how do you parameterize and drive the material characterization of a material flow that has huge variability. And really the place to go forward with that is in machine vision. And so very early on in 2016, we basically launched a product which was a robot at first, but is really focused around AI, machine vision, and how do we get the data back out of that system. And the reason this is important is because we're really looking for how do we drive parameters to the material stream. And this is going to sit at the core of what we talk about with data and with intelligence as we go forward, and how we're leveraging that into our future products, current and future products. So what we've really done is we've taken that technology and we've branched it out across a bevy of different products that we have, really looking at it in a more holistic way. I think our first application of this was really around robotics. We used a simple Delta bot. We applied the machine vision. We now use that for quality control. We use that for all the information that's coming back out, as far as we can do that on residue and recovery lines. We're also applying that in C&D, fiber, containers, all the different aspects. As we've looked at this, though, we've expanded it out to not only drive greater capabilities within the robotic systems, but also understanding that, you know, there's a large portion of the MRF population, material recycling facilities, that are not going to be greenfield. They're going to need installations in what they have so that they can drive efficiencies today. And so that really led us to the introduction of a couple of other products in our robotic offering, which is around the AQCC, which is a collaborative offering. Allows us to install that next to people, allows us to use that in some very tight spaces. We also have offered AQC Flex, which is for larger material, heavier material. And then a product that we're going to talk about, a technology we're going to talk about a little bit later, is really the application of machine vision and AI to optical sorting. And I think it's important to mention at this point is just the way that we talk about BHS as having a very holistic offering and a very broad spectrum of vantage point. We've also done that in the fact that by coupling the AI with our optical sorting, we now have the ability to cover very high throughput applications, areas that, you know, robotics just aren't going to get the job done. And so we view that as obviously a core supplement to what's going on. When we talk about material characterization, we'll cover that in just a little bit, but one of the questions that's kind of popped up here is, you know, when we talk about the information that's coming back in its current distribution and current product, it's really talking about it from a count perspective, material that's passing through, but we do have a couple of applications that are doing actual mass. And we'll talk about those when we review kind of our total visualization system a little bit later on. So when we looked at, you know, where can we apply, where can we solve some of the core issues that we see within material recycling? It's always about three real core pieces, right? It's about the recovery of material out of the stream. It's about the purity to make sure we're driving, you know, a good return on capital investment. It's also about the throughput. How can we handle more material effectively? When we looked at the way to act on that material, which is kind of the see-think act as the way we review, we really recognize that having the machine vision embedded in the opticals so that the opticals can not only couple the data together and make a fused decision, but also act on that in air jets was critically important. And so what we basically did was basically coupled our AI vision system with our optical sorting. We can do that in both color and NIR. And then we use that to make very high-speed, sophisticated decisions, basically fusing the data together. On an order of magnitude, you know, optical sorters can make around 10,000 to 20,000 picks per minute, if you want to define it that way. Even some of the fastest robots, you know, on the market sitting within, you know, 120, realistically more like 85 or even 60, can't keep up with that. And so really this is to drive towards, you know, how do I solve complex sorts in a very high throughput application? And really, this is highlighting a couple of the installs and a couple of the places that we've used this technology and what we're seeing for returns for the technology and really driving around the high throughput. And this can vary anything from HDPE versus a mixed rigid sort. We can do film sorts. We can also look at, when we talk about brand recognition, we can see this as far as, if we think about some of the common full-line bags that we see out there, we can drive the definition between PE, PP, and whether they're snack bags or what goes into that. And this is really the workhorse that sits at the center of a lot of our autonomous processing. And the reason is because it's just such a high volume piece. You're never going to see the day where robotics replace optical sorting, nor will you see the day when optical sorting replaces mechanical separation or density separation. Those pieces all have to work together, and coupling the detection technologies just allow us to further build on that and to further extract the data out of those systems to really drive important changes in throughput. To date, we have roughly 37 different applications of this all over the world since we introduced the technology in 2018. And they're doing, again, everything from fiber sortation to different forms of polymers to, determining even the shape of different polymers, right? Trays, PET, bottles, so on and so forth, as we look at that system, right? Building on what we were doing with AI, we really recognize the need within the space, again, talking about the large portion of material recycling facilities which don't have recycling, which don't have the opportunities for large high-tech renovations. It's important for us to be able to apply that technology in those spaces. And so part of what we've introduced, and we're using this in a couple of facilities now, is the ability to apply vision systems to belts. And really the functionality that these systems are providing is around just to do material characterization and information coming back. And, why is this important? Well, anybody who's spent much time around true manufacturing or industrial processing, especially in some of the early years, if you were an intern or you worked in those spaces, knows that one of the first things that you're required to do is go around and just measure, right? You measure quality, you measure throughput. If you're in a welding application, you're looking at how many welds are coming through, what's the quality of the welds, what's the product that I'm producing, how many of those are coming through, what's the process look like, should it be reorganized and reshaped? And the way you do that is lots of measurements, right? And really the question is, what could we do to bring that to the waste industry? And the way we've done that is by taking our vision canopies and basically being able to apply those to any belt within a facility and feed that back to a main HMI system. What this means is now you're getting this information back in a real-time way, allowing a number of different things, not only to understand the quality of the material that's going out, but also to identify if there's an issue within the system. Do you have a piece of equipment that's not performing like it should? And really, how do you drive building awareness around that? And also then building out cases for, how do I justify additional pieces of equipment in the system, right? If I've got a huge amount of aluminum content that's going out through my residue, how do I justify that? Well, one way is to piece count it, is put somebody there with a clicker to look at it, do a material comp, manually. But what we recommend is really to put a system in place where you can physically look at this and see what the variation is, see the material that's there, and then be able to justify when you make the change. Do you need a bigger eddy current? Should you be processing in a different format? And can you adjust that and then understand what the variation is from pre and post install of those pieces of equipment. This is also back to kind of our core driver. One of the big pieces that we're constantly looking at is in every facility, not only ones that are native BHS facilities, but also facilities built by others, is to really understand what's going out the residue, right? And that really speaks to the diversion. How are we driving and how are we helping companies to kind of reach their core ESG goals within any given system? And I think that's a big important piece, especially when you talk about enterprise-wide endeavors. So if you're a organization that has multiple MRFs, how are you making sure you're tracking all of that information in a very cohesive and collective way so that you know that things are measured the same, right? I mean, one of the true benefits of machine vision over human performance is the fact that you reduce the variability that happens. Machines typically perform the same way. Sometimes that's good, sometimes that's bad, but overall it's consistency. And if you look at any manufacturing process and you're trying to provide some of the core fundamentals that sit within industrialized processes today, whether that be Six Sigma or some of the others, it's really how are you driving out the variability in your process? And this is where our Totalvis product comes into play and really helps to build on driving that forward and being able to capture all of that data in a number of different places, right? And so what we've done is, in many cases, you can start to offer lots of data, and that becomes quite overwhelming. And what we've done with our industry experience is to really come back and say, okay, how do we drive an intuitive look at the information that's coming in? And how do we allow people to have more control over how they want to cut and slice and process the data? So one of the things that we put forward is our plant-wide Viz dashboard, Totalvis Dashboard, which essentially now allows users to have access to this information that's coming in and be able to convert and process that in a number of different ways, whether that's looking at it in the typical histograms or long-term trend plots, but also looking at heat maps for processing days and all these other aspects, really allowing customers to take control of the information that they have and allowing that to feed into their business process. And I think that's the other core that is really driving for us, is that we want this to be usable. The last thing that we're interested in is selling pieces of equipment that are not used. And, for us, that's such a major point that's where we want to draw in the conversations around what we've done with opticals, what we've done with robotics, what we're doing with controls as well. And that was one of the big pushes for us in many places. And so with what you see here is really the dashboard giving you the flexibility. Coming out of this, there's also the ability for customers to drive changes as well as to export the data out. We do have some customers who are very savvy from a technical data standpoint, and they want to be able to export that out and use that. You have that avenue as well. And that's where we're really seeing this being used in a couple of applications. And maybe I should speak to those for a few minutes here. We have really kind of a couple that come to mind. One is obviously a facility we're going to talk about a little bit later, and we're kind of constantly bringing up, but a facility we have in Oslo, Norway, which is probably one of the more cutting edge facilities around its use and as well as the operators, where they're not only using the data coming out of the system to make operational decisions, but they're also using that commercially to drive changes. We've had a couple of other customers who have looked at the vision data coming out of various pieces of equipment, and that's been used to understand performance operations as well as to provide justification for expansion of equipment or the replacement of equipment. So in the case of opticals, if there's needed situation where an optical may be undersized, there's the benefit to being able to put that together and take a look at that in a broader sense, right? So I'm going to answer. I'll pause here and answer just a couple of questions here. Maybe I didn't touch on it, but all of our equipment at this point, doing a quick check, is really we have facilities and applications and installs really around the world. So the specific question that popped up here is around NIR and AI in Europe. We do actually have a couple of installations, several installations actually in Europe, doing a number of different sorts and coupled with NIR as well as coupled with color. And then another question is the one that always seems to come up is basically the comparison of our vision system performance to manual sorters. We have done several comparisons of that. I think we're continuing to do that. I think that's the evolving portion of machine vision. In the applications that we have done so far, where we've done some very detailed material studies for both fiber purity as far as audits, as well as PET purity from an audit standpoint, the data is extremely close. And it's being driven in one of those applications where it is being used for commercial interactions. And in another, those discussions have started, and we're expecting those commercial, interactions and discussions to be kind of resolved probably the middle part of 2023. It's always a very complicated scenario because the one aspect of manual sorting and really material composition is kind of the human aspect. In general, people don't have a lot of mechanical sympathy where they have a lot of sympathy for the people. And so one of the things we've had to do is actually go back through and actually quantify what is actual manual performance, because we know even some of the fundamentals of basic, productivity manufacturing from the early 60s is around people don't do 100% on their processing, right? So that's where we're driving, and that's where we're looking for kind of the next steps of how we're expanding this technology, right? So understanding now what we were seeing with both driving data into the systems, being able to make high-speed sortation with our optical sorting, also being able to do quality control through robotics. We really knew early on that there was going to be a need for how do we drive system control? How do you really be able to elevate and use the information that you have coming forward to be able to make decisions within the facility? Because so much that goes on within a facility is not about the technology centers. It's not about optical. It's not about robotics. It's about how are you moving material around? How are you running your baler? How are you managing your tip floor? All of those pieces come into play to really drive a successful functioning material processing facility. And so really early on, 2017, 2018, we deployed our Total Intelligence platform. And we basically, now this system allows us to funnel all of this data that's coming in from a multitude of different sources, all of the intelligent pieces of equipment, as well as level sensors and motor speeds and all the other things that are going into it, and be able to drive a real interactive functioning system where a single operator can now leverage and utilize the system as a whole, being able to drive that from a metric perspective and understand in real time the changes that you're making to these pieces of equipment. What is that meaning to an operator? How am I matching up against my recovery goals? What am I trying to drive towards? If we talk about relationships with municipalities, one of the core KPIs is what's diversion, right? What is that looking like? And really giving an intuitive look for operators to be able to kind of control their own destiny, so to speak, a real front-facing HMI that basically allows that capability so that an operator is not having to manual sort material, look at what's coming back out of the composition, walk down to an MCC, adjust a speed, turn a knob, do whatever, and walk back. This is all now happening in very real time. And that's the whole purpose of what we did with our Total Intelligence platform. At this point, all of our BHS systems going forward are using Total Intelligence. And it's really driving a fundamental change in how operators are looking at not only the functionality of systems, but also how are they now able to control real KPIs around the functionality of the system. not only just talking about uptime, downtime, but talking about the purity of the material that's coming through and having the tools to change that all in a very real-time space, right? As I highlighted earlier, this is a facility we've had going for some time. It's really becoming a fundamental case study for us, not only around just the performance of the system, which is really what we were talking about early on, but really a durability of technology perspective. And long-term, what do we see for the needs of some of this new cutting edge technology from a maintenance perspective? And how do you really need, what's needed to maintain that? What we're really seeing is that it's not a lot, surprisingly enough. I probably shouldn't say that, but it is. When we look at the information that's coming back, we have a system in Oslo that's really functioning at a very high level and able to produce a very high quality material that they're using data from to drive very successfully with in a number of different attributes. And it has a bevy of our technologies, from robotics, optical sorting with AI, as well as the total controls. And it has a vision systems on the back, which are basically qualifying the material as it's going into the bunker, which is a big piece for them when they talk about, how do I reduce labor in the system and drive confidence? Well, if I've got somebody manual sorting, that is yet another, from a compositional standpoint, it's yet another body that we've basically reduced so that we can help to drive further investment in the recovery of different materials, right? So then, building on all of that technology as it was coming together, our long-term vision has really been around autonomous processing. How do we take systems that are processing a huge variety of materials and truly industrialize that so that the manual involvement and decision-making is really minimized? And the goal of this is to drive capabilities around variability, meaning how do I respond to variabilities that I see in the material? It's also to drive consistency within the business practices of what's present. And so the way that we knew we had to come about this is to really start off with core simulation practices, which are used in a number of different areas, and to really build a digital twin of a facility that's being ran. And so what we did was actually develop a internal program, internal architecture, basically building on our multiple years of experience to be able to simulate true facility performance and then understand what that means in real time. And so what this does now is it gives our customers and partners the ability to simulate systems and variability in material streams even before we run the first piece of material. And this is becoming a very powerful tool because it really accounts for these things that you're not aware of, right? It accounts for what we see from transitioning from the typical practice of, okay, I've got a basic material comp to what do we really expect that material comp to be? And more importantly, what do we expect the societal changes to be? And how are those impacting the material that we're coming in? And what's that going to mean for our recovery in the next 5 years? What does that mean for our diversion in the next 10 years? Am I going to be able to respond to those changes? And through building this simulation tool, we're now able to look at those and understand what's the offset of different pieces of equipment, what's the proper sizing, what's the proper processing steps, right? And really build in a capability that's really showing some significant value as we go forward. Again, taking us out of what most are looking at, which is a static material stream, and really adding the variability into it so we can really truly simulate what's actually there, right? The last piece that I want to touch on, and I want to spend some time sitting here for a little bit and really talk about one of the latest technologies that we've deployed. And it's really around our autonomous processing system. Lots of press releases about this and what's going into it. And so what I thought we would do is spend some time really about not only the functionality of this system, but talking a little bit about why this system was built. Why was it put into place? And what problems does it solve, right? Really, when we took a step back and we looked at the functionality of any given system, we started to realize that as you looked at larger and larger systems, you really avoided or you kind of eliminated or minimized the amount of impact that some of the smaller systems have. As we look around the country, most of the new facilities that have been built are ranging in the 20 to 35 ton per hour or larger, right? The issue to that is there's still a large portion of society, whether that be in the US or Europe or the rest of the world, that's doing large amounts of manual sorting, that's doing large amounts of non-automated processing. And so the question is, what's really the barrier to that? What's keeping that from being more largely adapted? When we look at the US population, we've only got about 55% of US population that has curbside recycling. And so when we start to triage that, coupled with why we don't see adoption of technology, we start to understand really two pieces that are coming into it. One being the fact that for some of the smaller systems that are out there, facilities that may be local municipalities, there's really a CapEx limitation to it. Even in today, where we're seeing large investments into the recycling of materials, there's still not enough being funneled to smaller recyclers and being able to leverage new technologies into that, mostly because just as we talked about recycling in general or waste handling in general, it was really viewed as a linear system, right? And what we know is that doesn't work for some of the smaller processing. What we also know is it has some limitations with the larger processing. And so what this pushed us to come about and really kind of bring forward as a technology, building on the other building blocks, is how do we drive automation within this system and reduce our capital footprint, reduce our space footprint, so that now we have a system that can adapt to variations in incoming material, variations in outflowing material, and minimizing the capital exposure, as well as helping with the OpEx of a system in some of these places which are highly constrained. And so what we came up with is basically this autonomous processing system, and it's a technology for us that basically builds on both our optical sorting, robotic sorting, vision system, and total intelligence, bringing all of those forward together to really drive autonomy within this system. And when we talk about autonomous processing, that's exactly what we're describing. This is not a person sitting on a touch screen making decisions on what material should be processed next. This is a system which has the ability to recognize the materials that are coming in, make decisions on what should be sorted, and make decisions on how to handle that material best. And so maybe in a simplistic way, what happens with the system is material comes in through the pre-sort AQC. Hoping you guys can see my mouse here, but we'll find out. Material comes into the main loop through an AQC sorter. We can use a vision system. This is really our first look at the material as it's coming in, basically allowing us to understand the composition of that material. From there, it's basically sitting inside of a couple of bunkers. And in these bunkers, they're holding this raw material in place. From here, the system operates in a circular fashion, meaning that there's one optical, one AQC product that's basically processing all of this material. It processes each material in a singulated pass, extracting the target material with each pass. So what that means is, in very simple terms, if I've got a material stream that's coming in that's made up of PET, HDPE, polypropylene, mixed plastics, it could have some other residue components to it as well. The system, from knowing what's on the inbound, makes the decision to process the highest commodity value and volume first, which could be HDPE. The material circulates through the system, extracting HDPE with every pass through the optical and AQC. Once it's extracted that total volume of material or HDPE from the system, it changes and processes to the next. It continues that until it's extracted all of the value from that material, and then it purges that whatever the remainder is left to be sent out and processed in whatever other areas that it needs to do. Then From there, the system is basically bringing in all this information and then can then produce whatever reports needed for the material that's going out, as well as the operational, typical operational metrics about uptime, downtime, everything else that's coming through. At its core, the system is designed to function completely independent of human intervention. So what that means is it now adds a huge amount of operational flexibility to the overall usage of the system, meaning that this system can run independently of breaks, lunch, all the other aspects that go into it. What this first iteration of autonomous processing is really focused on is around containers. So this iteration of what you're seeing here is requiring some screening, some additional separation on the front end. You're moving large OCC out of the system. You're removing, any large hazardous materials. You're removing your entanglement items. You're removing all of the other things that you might do in a pre-sort application, and then sending what would be considered the container line material into this processing arena. One of the things that we're working on and we'll be releasing soon will be a package that we can deploy in a number of different areas that will focus on what does the entirety of the package looks like, meaning including the screening aspects, the density separation aspects, and all of those into one centralized package. At this point, the system that you're looking at here is processing roughly 2.5 to 3 tons of total inbound material, and is able to process the recycled, container material at roughly a 6.5 ton per hour rate, basically allowing you to have an in-feed system that provides all the in-feed commodities, and then now have the ability to run those two independently of one another, right? So you can run this container line in the back end. It can run 18, 20 hours throughout the day, processing all of the containers that might be present of what you're wanting to remove. The front end system can be ran on a typical, 8-hour shift, 10-hour shift, whatever you want to do with the appropriate lunches and breaks. Doesn't impact this back end system at all and how that it functions and how that it works through, right? So really, again, highlighting this is really meant to be for some of the lower volume applications where you've got processing that needs to be done in an automated way because of the need for higher commodity recovery purities, or in systems where there's a significant limitation on even processing footprint, because I think that becomes a major constraint in some of the much larger systems that are out there, right? I do want to leave some time for questions at the end, but one of the big pieces for us is really around, again, how do we minimize the risk associated with operational pieces that are going into operating large scale systems, systems of all sizes, and really looking at how do we build best operational practices across the board. And really autonomous processing is just one piece of how we do that. And how we're really trying to leverage technologies to really help MRF operators, to help municipalities, to help facilities grow and have access to a lot of the new technologies that are out there, and to really look at how can that be impactful, not only from true ROI commercial KPIs, but also looking at trying to hit the diversion numbers, and how do we really build on circular economy, and how do we drive the changes? I think, as we look at the market space in general, as we look at waste handling in general, it wasn't but a few years ago that chemical recycling, advanced recycling started to come on strong. You've had some very early players that have been around for many, many, many years. The success is still out on some of those, but some of them that have been around are really starting to gain steam, and we're starting to see the landscape changing. I think that's going to continue to carry forward. And our objective and what we're really trying to drive for is how do we build adaptability into the systems, both not only to minimize the risk, but also to help build and leverage how do we drive the efficiencies and really drive diversion, keep things out of the landfill. As I'm constantly reminding people within our company and really talking about, what are we doing to make an impact today? It's really about the fundamentals of, everybody enjoys the green grass. Everybody enjoys clean air. Everybody enjoys fresh water. And that's something that BHS really wants to carry forward and continue to move. What I'm hoping is at the end of this session, if there's questions, if there's discussion points, I'm happy to get into those and we can talk about, any different portions of the system, this presentation, or I can get you in touch with some of our other, some of my other colleagues, right?
Thank you so much, Thomas, for a great presentation. We do have a few questions, so we do have some time for those. So we'll start with, how does your data acquisition system work with other manufacturers' equipment?
Right. So we've done a couple different things with acquisition. Really, what we've done to help broaden the spectrum is a couple pieces. One, in European applications, we do Profinet functionality. So we don't necessarily allow direct communication between our vision systems and other pieces of equipment, but we do have a functionality where customers can integrate that data into other systems that are present. We also, as I spoke about just a little bit ago, we also have the functionality that customers can export the data out into a couple of different SQL formats, Excel formats, all these other pieces that are pretty commonly acceptable, just because we want people to have that functionality. And we realize and appreciate not everybody's going to be, ripping out a complete system and putting in a full BHS system, right? So.
Another question we got from the audience was, does the autonomous facility require pre-sort conditioning, removal of contamination, hazardous material, large fraction screening, et cetera?
Right. And currently, the current autonomous processing, which is the autonomous container line that we're really offering, is set up to have that pre-sort done in the front end. So removing large items, removing OCC, also removing kind of the non-container portion of that material. So that includes all the 2D material that might be present. All of that is done pre-processing to what's going into the autonomous portion. So it does require that additional screening, large fraction removal portion.
How can AI help products to be more marketable?
Yeah, that's a great question. So a couple of pieces that can go into that. One is really around being able to qualify material, knowing what the actual purity is of, we talk about bales. Bales are really kind of the unit term that's applied to commodity exchange, but really understanding what the purity is of those commodities that are in a given bale is incredibly important. That is absolutely what we're seeing out of a couple of customers that are using it for both fiber and PET, is that they're seeing a positive return on being able to describe the exact purity of that bale, which then allows them to balance their system and negotiate as to what should be the currency exchange for that, right? Because I think in historical terms, and maybe even if we'll describe kind of the state of where we are in recycling and commodity exchanges, it's historically, I'm going to pull a small sample from a large load of material. And if that looks good, then I'm going to assume that's homogeneous across the entirety of that every bale is going to be that way. We know that that's not the case. And I think the industry knows that that's not the case. But the problem is it's just so expensive to be able to do that we kind of let it go. And so I think really trying to drive the commercial aspects of applying, vision and real-time compositional so that you're measuring this continuously has really allowed some customers to leverage that at a very high level. It's also allowed, open discussions to be had with consumer packaging groups to basically understand how much of your containers are actually being recycled. Where are they going? Where are they ending up? And I think that's really from a societal change. While the question was really focused around adding value, from a societal change and how we're going to have impact on things going forward, it's really bringing that data up to us as the consumer so that we understand what packaging we have and how is it being used? How is it being recycled? Does it end up in the landfill? Nobody at their core wants to say, yeah, I bought this great new television, but all the packaging ended up going to the landfill, right? That's just a soul crushing thing, right? So that's the way you can use it in a couple of different ways. So.
Yeah. We got some more audience questions. Does the Total Intelligence platform capture material mass for tonnage estimates?
Yeah, so the Total Intelligence platform can absolutely be integrated into with scales. We can do scales, we can do volumetric scanners, and we've done that in a couple of different places so that you can, not just estimate your tonnage, but actually measure the tonnage that's coming through and measure the volumes of material. Part of what's being done in the autonomous processing system, while we don't highlight it because it's not glitzy and glamorous, but in every one of the conveyors and in the bunkers, there's all measurement devices, which basically allow that system to control and understand the flow of material to make sure it's optimized and to also make sure we're measuring what are those outbound pieces of information as far as the material goes.
Okay, more from the audience. Thomas, it says, with the simulations you have done on a complete MRF, is there a sweet spot or sweet spots in terms of throughput to optimize CapEx? Apologize.
Yeah, CapEx. So that would be the capital expenditure. Yeah, no worries.
Newbie to the semi-newbie to the industry. That's my fault, everybody.
No worries at all. So that's a very interesting question. It actually comes back to not only the throughput. It's a very unique system, right? It's not only the throughput, but also what commodities are you trying to recover and what markets are those going into? So for the applications we've had in the US, we see a different space because of the number of commodities that are returned and what we're seeing for example, in California, where you might have a redemptive value that's going into certain commodities versus what we might see in Europe. So to answer the question in a very pointed way, not yet do we see a real sweet spot for where that exchange is happening, but we would love to have conversations with customers around what they're seeing, what they're looking for, so we can use our simulation tool more and exercise it. We've obviously built, BHS on order of magnitude equipment has processed billions of tons of waste, right? So we have a lot of information coming in, but we're always looking for that next step. So haven't really determined the sweet spot yet, but I'm sure we'll continue to look at it and figure out what that needs to be. So.
Thomas, can data acquisition with AI replace manual material audits?
Long term, that's the goal. I think what we're seeing today is that we absolutely see it as a very strong supplement where it removes a large portion of that need for those audits. So you have the ability to see this data coming in real time, and you can then utilize that as a long-term trending information and the ability to really calibrate yourself to what the system's doing and what the market's going forward. Even in the systems which are very controlled, even in the systems we see where customers are using the data to trade on a day-to-day basis within the commodities, they're still doing some portions of small material audits as part of it. So we think it's absolutely a very strong driver and supplement to what's going on. We do believe there's going to become a day where it completely replaces manual audits. We're not there yet. We're still working on it. We're still trying to drive towards getting information back. I think one of the core pieces that, sometimes in these talks, people don't talk about the good things and the bad things, but to be completely transparent, one of the things that's always a struggle is how do you measure the mass of material? And so we're working on a number of different new technologies of how we do that, because the industry trades on mass. The industry didn't trade on objects. And so we've had a number of successful cases where we've been able to do that. We've really got to drive that forward and be able to implement that everywhere. We do see that the vision systems drive a huge amount of significant value around trending and understanding how that material is being dealt with.
I think too, a question a lot of folks are interested in, how does then the design of a MRF change when we're talking about AI and automation and implementing those things?
Yes, that's we see that having a huge impact on MRF design. And the fact that, AI, whether you're talking about some of the more, what we'll describe now as simplistic installations, which would be robotics and maybe even some of the more complex opticals and AI coupled together. But even when we talk about more of the autonomous processing, where we're using AI to really just change the whole concept of how we process material, that has a huge impact, because so much of the system design today is driven from what can I do for accessible labor? What do I have from a footprint standpoint? What can I, if I look at some of my power factors, even from how I run a facility, when do I need to operate? When do I not need to operate? I've got to put all those pieces in together, really make my decision of what does this facility look like on top of all the recovery, purity, and throughput things I'm trying to do. So as we add a ton of, AI and machine vision and all these pieces into it to drive autonomous processing, we see that some of the constraints that we had previously are removed, right? The scheduling runs and everything else. So what we anticipate is really a reduction in, capital expenditures that go into facilities, and a focus really on the operational expenses and what's going into that, and how do we really drive kind of an optimal point for both of those. And, even something as simple as footprint reduction, steel reduction, I think the recycling industry is got to continue to drive, ESG goals even within itself, as to how do we limit the waste? When we tear a facility out, where does that go? How's that recovered? What's being used for that? What are we doing for wear items? Are those being thrown in the trash and sent into landfill, or are we finding new ways to recover those? So I think all of that kind of funnels in, and the more we apply, smart processing, simulations, AI, all those things help us to really build a more holistic view of our impact on the waste stream and facility design from being more efficient in it.
Another question we got, Thomas, from the audience: are there computer vision applications generalized to handle new CPG products, or is this part of the commission process to tweak these models?
So it can be done in both ways. It'll depend a lot on, some of the broader spectrum CPG products we can look at now and have a high efficiency. Some of the ones that are more nuanced, it requires more tweaking and more working on models to build to that technology. I think overall, as we carry it forward, I think everybody within this space is trying to work to build more robust models, a broader look at what's going on there. And so I think we're continuously working to do that better. I often frame that some people look at, okay, I'm going to have to, work with a model. That's the same as when you have to train people in some cases, right? You've got to do some of that on the front end to get yourself to a better place. And we view that as just a way to get to higher performance, right?
And then finally, Thomas, I want to kind of end with where you see the implementations of this technology, even in the next 2 years or 5 years. How do you see this evolving and being implemented throughout the industry?
Yeah, for us, two core places that are really going to have the greatest impact. One, the ability to drive industrialization and automated processing is going to be the one that's really going to be a very heavy hitter. Especially, you can't look anywhere. No news outlet doesn't cover the labor issues that are happening everywhere, right? And so we absolutely see autonomous processing as being that piece. The other part is really around the data and vision systems. And it's not just in some of the fundamental ways that we're using them, but I think it's going to be, there's new ways that are going to come forward of how do we drive understanding and social awareness even of what's going on. And I see those as becoming systems that are not going to be optional anymore. I think you're going to see that as becoming a mainstay technology. that's going to just continue to push forward and going to be almost expected from municipalities. It's going to be expected from the general public. It's going to be expected, just from an operational standpoint of what's going on, what materials coming in, what materials going out, and how do we adapt to what's there so that we can really, have an impact on what's going on. If we're operating in the dark, there's no way we can make the improvements that we need to really build ourselves up. Look, it really comes back to this. We didn't end up in the place we are today in the waste constraints and the plastics problems and all these different things that we have that are coming at us overnight. We're not going to solve those overnight either, but we absolutely have to be forward looking enough to understand that we've got to start implementing these technologies today to really have a driving impact and be able to set ourselves back to not only a sustainability, which seems to be the term that's used, but I want to put it back to better than what it was, right? And that's kind of our fundamental driver that sits within all these. So the autonomous processing and the vision systems are just going to be such a huge piece that go into that over the next couple of years.
Great. Well, Thomas, thank you so much. For folks who maybe didn't get their question answered or maybe have more they want to ask, is there a place they can reach you? I know there was quite a number of questions we weren't able to get today. So where can folks find you?
Yeah, so they can absolutely contact me through my bulk handling email address. They can also go to our webpage, bulk handling systems, BHS or NRT. Any of those will be able to funnel them in and get them to the right person that can answer their questions. And probably some of those might come to me. But happy to answer those questions and talk to people more about what we can do to help drive change. So
great. Well, thank you so much. And thank you so much, everybody, for joining our session today on MRF system data and intelligence and those real world applications. Thomas, thank you again for your time. A really great presentation today.
Thank you, Marissa.
Thanks.